Assalamualaikum warahmatullahi wabarakatuh to all panel and whatever person watching my research proposal video. So my title is about computational study of a model wind catcher with different incident angle. First, let me introduce my name. My name is Nabil bin Norzamri and my student ID is 2018 to 87632 and my supervisor for this research is Puan Merlisa Binti. So we go to the introduction part. Wind catchers are architectural elements that we used in ancient Egypt to naturally ventilate indoor air. These elements are still used in the Middle East region, including the small Arab states of the Persian Gulf such as Dubai, Pakistan, Afghanistan. Wind catcher can be categorized to one-directional, two-dimensional, and multi-directional, depending on the direction used to catch the wind. They can be further categorized based on their design, whether they utilize descending or ascending air current. The top part of the tower is installed in a high place, such as chimney, and is blocked on all sides but one, which has an open structure to draw in the wind. The wind coming through the open side creates a descending air current that falls toward the room center and cools the room. So, the function of the catcher are to lower the room temperature, and it's all about natural ventilation that uncontrolled movement of air into a building through a small hole called infiltration, and through vents such as windows and doors. The conventional way of activating fresh, natural air to replace indoor air. Nowadays, because of the central heating and cooling, as well as the desire for privacy, people tend to make a little use of the window for ventilation. So, ventilation has become the principal mode of natural ventilation in homes. Okay, so that's for introduction for the wind catcher. So here we go. So for the following statement, as nowadays people should decrease the use of the energy that can cause destructive to the environment. From past up to now, many techniques have been implement to make life more comfortable, and using fossil fuel was considered significantly. Climate change, air pollution, destroying organisms, and global warming are all the negative effects on fossil fuel consumption. The use of renewable sources has become global phenomenon, and people are eager to apply them. These sources include wind, water, soil, and sun that are inexpensive, and according to the climate, a certain type is used. Among them, wind power Wind power plays an active role in providing thermal comfort and natural ventilation in buildings. So my objective in this research first to determine the velocity of the airflow inside the model building, and second is to identify the air ventilation rate in wind catcher and the building. So for the scope limitation of the project, the aim of this research is to understand the performance of wind catcher with different incident angle in generating the best airflow for stable building. Using two types of building with different position of window, that is adjacent window and opposite window. Study will also with variety of wind speed, which is 1.8 meter per second and 3 meter per second, as this speed is average speed environment at Malaysia. Study by Hole on 2016. The study could give some important insight into the innovation and knowledge of wind catcher in Malaysia, which may be useful for further improvement of the methodology. The methodology. So is my flowchart. The strategy of the methodology consists of the analysis of numerical and experimental capabilities using CFD to solve the need of evaluation. The purpose using CFD is to evaluate the airflow rate inside the wind catcher and to identify the air ventilation rate in wind catcher and the building. So my first box in the flowchart is to determine the important parameter for wind catcher. Then I will build the basic model for wind catcher in CATIA using the specific parameter. As a CATIA is a multi-platform software suited to this study since it supports multiple stages of product development from conceptualization, design. So this computational study will be using CATIA software for modeling process before being computed in CFD software. And then the third part is the develop the CAD model using ANSYS to obtain the objective. And then the last box is our flowchart is using CFD to observe the velocity of airflow and air ventilation flow rate. As you know, the use of computational fluid and dynamics called CFD as design tool, and also for numerical prediction for variety result depend on the software. This research will be using ANSYS. The objective of this research was to implement different incident angle for the wing catcher for evaluation by integrating CFD study for the optimal incident angle. This approach is a cost-effective method as compared to conventional method to develop feasibility study for the implementation of wing. So that's all for my methodology. So for the model of geometry, in this study, we will be conducted by using two types of wing catcher, building as the position of the window. As you can see, at the window at the adjacent to the wing catcher and the opposite to the wing catcher. Then, so on the top right side is the figure of the top view of the wing catcher that will be conducted with various of incident angle such as 0 degree, 15, 35. While the table shows the specification of the model geometry is the position of the window outlet, adjacent and opposite, dimension of the building, 8 times 6 times 3 meter, height of the wing catcher is 1.5 meter, and convert to millimeter is 1500, dimension of the wing catcher 1000 millimeter times 1000 millimeter times the height, size of the window is 1000 millimeter times 1000 millimeter, and the porosity of the ratio as the area of the wall, the area of the window divided by the area of the wall, and that's the 0.011%. So for the turbulent models of this wing catcher is used for the simulation is K epsilon. The use of this turbulent will solve two variables as the turbulent kinetic energy K and the epsilon as the rate of dissipation of the turbulent kinetic energy. Wall functions are used in this model, so there's no simulation of the flow in the buffer field. The K epsilon model has recently been very successfully for industrial application due to its excellent convergence rates, relatively low memory requirement. Okay, so for the specification of data in computer fluid dynamics, the specification of data that will be key in the CFD simulation, such as the turbulence intensity, the velocity inlet. They have two varieties. There is 1.8 millimeter per second and 3 meter per second, and the grid independence evaluation was carried out before the actual CFD simulation was performed. The key purpose of the grid independence is to define the number of elements that should be added to the experimental count, the speed of the flow velocity of the grid, and the independence test was 3 meter per second. And the right figure is perspective view of the domain, and there's a dimension for the domain, and including this in the middle is the wing catcher. So here is my preliminary result. In this simulation, using specification of 3 meter per second in the inlet and the wing catcher building model with opposite window, and the incident angle is at 0 degree. So the top is the result of velocity control. So as you can see, the crucial part at the middle that will be choose for the variation result and the result, as you can see after this slide. So the bottom one is the streamline of the velocity. So we go for the next slide. So here we go for the validation result. So the result below show the graph velocity of the center that are been taught just now. The center inside of the model are chosen in the wing catcher, as the graph of the show that the velocity divided by u reference. As my u reference is 3 meter per second and proportional to the distance. So here is the first graph, is the graph of the displacement of y versus velocity divided by u reference, and same goes to the three graph. The result was compared based on the velocity was compared to the valid my result by Montazeri paper on 2018. So the cross axis of the building was selected on the basis of the critical component, which can be seen by the figure of the velocity control result from the slide just now. So for the validity result, letak on the result in orange point on the two graph. on the left, and the reference value of the research is for my research is 3 meter per second, while the view reference that compare for the validation result is 10 meter per second. So here is the result of velocity of 0 degree incident angle and other outlet at the opposite position. So as you can see, there's a model geometry model on the top right of the graph, as there's a line, red line, that's the represent the distance that I calculate for this graph. Okay, so for my expected result, for at the end of this research, so maybe the highest velocity airflow indication at the incident angle of 0 degree, and also the efficient air get the most efficient air ventilation, and all the dimension will be significant at the Kata software and import to NCS. And as we then simulate the using data that is significant as velocity inlet, incident angle, and pressure. So that's all from me. Thank you for lending me your ears and concentrate on my presentation research proposal about the computational study of a model we can show with different incident angle. So if there are any questions related to my presentation or my study proposal for the panel, you can just contact me through my email as I mentioned in the description below. So thank you, stay safe, and stay at home. Assalamualaikum.